We're going to look at solving logarithmic equations. Now, the first thing that I want to make sure that you understand is that you want to get the logarithm by itself when you're solving. Okay? Now, the logarithm ends either in one of two circumstances: after the variable has ended or when the parentheses end. So here, there's no parentheses, so it's after the variable. On this one, there are parentheses, so the log ends here. So I'm going to highlight the part that we're trying to get alone. So these ones we're getting alone, this we're getting alone, this one we're getting alone, not the 6 with that, just the log, just the log. Okay. So again, this one does not have parentheses, so it ends after the b. All right. So that's the first thing that you need to realize is what you're getting the log, what it is the log that you're getting alone. I did not say that well. So the log starts with the word L, or the letter L, and then ends either after the variable or when the parentheses end. So notice here that if we had a number in front, like this one, we didn't include that. We didn't include the negative. We didn't include the number in front. We didn't include anything being added or subtracted outside. Okay? So that's the first thing that we need to do. Okay. Now, this is very much like solving or finding the inverse of a log. You're going to get the log by itself, and then you're going to undo the log with an exponential. So we get log alone, undo by switching to exponential, and then you get the variable alone. And again, we get the variable alone by doing the order of operations backwards. Same with getting the log alone. You still use the order of operations backwards. Okay? So on this first one, we have nothing outside the log, no adding, subtracting, no multiplying, dividing. So the first step that I need to do is undo the log. Well, we undo the log by switching to exponential. When you switch to exponential, you start with the base. The base is 11, so I'm going to do 11, hop to the other side, which is to the third, hop back, which equals b. And then you can just use your calculator and do 11 to the third, which gives you 1331. So b is 1331. Now, if you don't love the hopping across the equal sign, you can do it another way. So if we look at number 2, notice there's no multiplying and dividing on the outside. There's no add, subtract outside the log, so I just need to undo this. Well, if we look at the base is the 8. So I'm going to do 8 to the on both sides. So 8 to the, 8 to the. So here, if we do 8 to the log base 8, those undo each other, and we're left with just n equals 8 to the negative 1. Well, if we take 8 to the negative 1, that's really the same as 1 over 8 to the first, which is just 1/8. Okay? So if you prefer to use the base to switch and the idea of the inverses, that's fine as well. Okay. Now on this next one, we have to get it alone first. So we have this plus 8 that we need to get rid of. So in order to undo the plus 8, we're going to subtract 8 to both sides. So then we have log base 3 of n equals 12 minus 8, which is 4. So then we're going to switch. There's no add, subtract, multiply, divide outside the log. So then we're going to switch to exponential because log and exponentials are inverses. So the base is 3, hop to the other side, so 3 to the 4th, hop back, equals n. Please make sure when you're writing 3 to the 4th that the 4th looks like an exponent. It's a superscript, meaning it's up above. Okay. So we have 3 to the 4th gives us 81, so then our n is 81. Okay. Now, if we look here at this one, let's skip over to number 6, we have two things we need to get rid of that are outside the log, or outside the highlighted yellow. So we have the 3 and the negative 10. Okay? You're always looking as to what operation it does to the log. So the 3 is being added to the log. Notice the add is really out in front. It's the 10. Notice the 10 is being multiplied and it's a negative 10. So some of you will be tempted to write plus 10 when you're undoing the 10 because of the negative in front, but the 10 is being multiplied, so we undo multiplying with dividing. So the first thing that we get rid of is our order of operations backwards. So we undo add subtract first. So we're going to undo the add 3. So I'm going to subtract 3 to both sides. So then I have negative 10 log base 12 of x equals negative 30. So again, you have to realize the 10 is being multiplied by the log, which means that it's a negative 10 being multiplied, and you're not subtracting 10 from the log. If we were subtracting 10 from the log, it would look like log base 12 of x minus 10. Or you would have it as negative 10 plus log base 12 of x. Both of those would be where you're subtracting it, 10. But that's not what we're doing. We're multiplying. So we undo the multiplying with dividing. So I'm going to divide by negative 10. So then we have log base 12 of x equals 3. So now I'm going to switch to exponential because our log is all by itself. So when we switch, we use the base, which is 12, hop to the other side, to the third, hop back, equals x. Or you can say, take both sides with a base of 12, so 12 to the, 12 to the. Okay? But the 12 to the log base 12 undo each other, so you get x to the, or x equals 12 to the third. And then we can do 12 to the third in the calculator, which gives us 1728. Now, if we were to put this in our calculator, to check our answer, you would do 3, subtract 10, and then you would do log 1728. And then you'd close your parentheses. So if you're doing the log divided by, you'd have to write it like this on your calculator. So you do negative 10, or sorry, 3 minus 10, and then you'd need for your parentheses. So log 1728 divided by log, our base is 12, and then close your parentheses. So you're saying you're taking the negative 10 and multiplying it by that whole thing. So divided by log 12. And then it will give me negative 27, which means that I got the correct answer. Okay? So that's how you can check your work. Okay? Now, you also can have things that are happening inside the log. So far we haven't had anything happening inside the log, but that's a possibility. So if we look at this next one, our log is already all by itself, right? The plus 9 is still in the parentheses, so I don't get rid of that until after I've undone the log. There's no add subtract outside the log, there's no multiply divide outside the log, so I switch by doing 5 to the first equals v plus 9. So 5 to the first is just 5 equals v plus 9. So then I want to get the v by itself, so I subtract 9, so we have negative 4 equals v. If we look at number 9, we've got the 6 that we have to get rid of outside the log, so I'm going to subtract 6 first, so then we have log base 12 of negative 3v equals negative 1. Then we have to switch to exponential form because everything outside the log is taken care of. The negative 3 is inside the log, so we do 12 to the negative 1 equals negative 3v. 12 to the negative 1 equals negative 3v. So 12 to the negative 1 is really 1/12 equals negative 3v. Right? We're trying to get the v by itself, so that means I need to divide by negative 3. Now that's really the same thing since I have a fraction on this other side. Instead of thinking dividing by negative 3, I'm going to think, well, I'm timesing by negative 1/3. So if I times by negative 1/3, then we end up, remember, to multiply straight across. So negative 1 times 1 is negative 1, and 3 times 12 gives us 36. So then we would get negative 1 over 36 equals our v. Okay. Let's try number 16. So if we look at this one, we've got something going on the outside, but we also have things going on the inside. But I want to get the highlighted part alone first. So I'm going to add 5. So then we get log base 4 of negative 9p plus 10 equals 3. The log is by itself, so now I switch forms. So you can do 4 to the, 4 to the, or you can do 4 hop to the other side to the third equals this. So either way, here the log base 4 and 4 to the log base 4 undo each other. So we get negative 9p plus 10 equals 4 to the third. So if we do 4 to the third in the calculator, we've got 64 equals negative 9p plus 10. I switched which side my, the two things on my equal sign, but that's still fine. So we subtract 10, that gives us 54 equals negative 9p. So then we're trying to get the p by itself, so we want to divide by negative 9. So then we have 54 divided by negative 9, which gives us negative 6. So our p is negative 6. Now we can also have things with our special bases, right? So if we look at this one here, okay, now notice on this one, the log ends after the variable or with the parentheses. So that plus 8 is outside the parentheses, or outside the log. Our parentheses are really unsaid right here. Okay? So that means I have to subtract the 8 first, since it's outside the log. So then we're going to do 11 minus 8, which gives us 3. So we have log of 2n equals 3. So now when we go to switch forms, notice there's no base. Well, hopefully you remember if there's no base written, that it's a base 10. So that's because our number system is in base 10, so it was one that we used frequently. So mathematicians by nature are lazy in their writing. So we dropped the 10 because it's something we used all the time. So there's really this unsaid 10 here. So we do 10 to the third equals 2n. Remember with your powers of 10, that whatever the power is how many zeros happen afterwards. So that's 1000 equals 2n. So then we're going to divide by 2, because we want n alone, so then we get 500 equals n. Okay. Now, let's look at this one. This one we have ln. Remember, ln stands for natural log. Natural log is just a number. It's log base e, and the base e is just our number. It's just like pi. Just use a letter to represent the number. So we're going to add 2 because we want the log alone first. So this is our part that's the log. So we're going to add 2. And then we have 4 natural log 9 minus a equals 12. Well, now I want to get rid of the 4 in front. The 4 is being multiplied, so we divide by 4. So we have the natural log of 9 minus a equals 3. Again, when we go to switch, there's no base. You have to remember the base with natural log. So your natural log has a base of e. So you're going to do e to the third equals 9 minus a. Okay. So the other way that you could look at it is that you would look at e to the on both of these, and then the e and the natural log undo each other. So you have e to the third equals 9 minus a. Okay. Well, we're trying to get the e by itself, right? So here, now I could put this in the calculator, or I could finish simplifying and then put it in the calculator. Both of them give you the same thing. It doesn't matter, so I'll show you how you can do it without the calculator and at the very end put the calculator. So the 9 has a plus in front of it, the sign. The sign in front is a plus, so we're going to subtract 9. So I have e to the third subtract 9 equals negative a. Well, I don't want negative a, I just want a. So that means I can multiply or divide by negative 1. I'm going to choose to multiply. I have to distribute this negative to both terms. So this gives us negative e cubed plus 9 equals a. It looked more like a 9. There. So now we can put this in our calculator. So your e button is your second and natural log. There's 2 e's actually. You have an e to the, which is the second, and the natural log, which is left of number 4. Or you have your second divide button, which just gives you e. So since I'm already raising it to a power, I'm going to use the second natural log. So e to the third, and then plus 9. So then I get negative 11.086 equals a. And that's how you solve your log equations.